Hello everyone, this is a video presentation on our course project ROV for Effective Underwater Research and Rescue. The origin and motivation of the topic is taken from Smart India Hackathon 2022 under the category Hardware. This problem statement was put forth by National Defence Response Force NRDF to use it for underwater search and rescue operations. This interested us because one of our teammates, M. Nitin, is already working as a part of AUV society. Now, who are the target customers here? The customer here is the people who are struck by misfortune during calamities, and this problem is to solve rescue issues of people when water-based calamities like storm or flood occurs. The customers here are accidental customers, since no one will knowingly become a part of a calamity like flood or storm. There are also scientists or marine enthusiasts who want to explore underwater and collect various data. They are also the customers for this. What is the intention of the ROV? Be from the customer's point of view. The ROV must be easy to maneuver, being precise at the same time. It must be robust to work even in murky water and stormy conditions. The next goal is to notify the collected data to rescue team with accurate parameters such as the features and locations of the customer or precise data to be collected. Camera or sonar images must be available even under murky conditions. Next, for the ROV to be smart, it should be equipped with features like being able to detect any instability and self-stabilize, and with intelligent algorithms to self-navigate. It must also be equipped with algorithms during inspections to send and analyze meaningful data with data analytics. It must be equipped with safety features to take decisions on its own in case of emergency. Problems that hinder the performance of existing systems. The current sonar system is less accurate because of murky water, less precision and maneuverability. Presently, the underwater equipment held with NRDF is based on sonar system, which has some disadvantages. The system generates lot of noise which depends on sound levels generated by sonar. The acoustic waves used in sonar are affected by sound velocity variations over depth. What are we expecting from this ROV? Based upon the existing issues, able to carry out underwater inspection in an effective, safe, and timely manner with high precision and maneuverability, capable of visibility in murky waters, equipped with intelligent software and high quality sensors that do underwater inspections, provide value additions through data analytics and intelligent navigation, provide set of images out of sonar for data analytics. What analytical limitations does the ROV have? Data must be collected by performing experiments in a large number of virtual experiences, since the actual UX is pretty rare. The safety aspect of ROV system itself is critical, since the virtual experiments cannot cover all the obstacles in trajectory. Must be able to detect the presence of both active and passive customers, and saving the active customers must be prioritized and the passive customers must be notified. Must be able to analyze vulnerability of active customers.
Till now, we have discussed the limitations of current ROVs, and also we have discussed what this ROV is expected to do. We have not yet discussed what makes this ROV so smart. This image contains all the traits that this ROV has to make it smart. The first is obstacle avoidance. So what this ROV does is automatically detects any obstacle flying towards it or any instability in the water to automatically correct the course to make it stable. We don't always need to manually maneuver the ROV since it automatically detects it. That's one aspect that makes this ROV smart. Now this can be achieved using cameras to detect any incoming obstacles or sensors which may detect the change in position, unwanted change in position. So the next one is low noise generation. Now this uses intelligent filters to uh, to gather more precise sensor data values. For example, let us take an example of calculating the orientation of this bird. So what we do is we will take accelerometer and gyroscope readings. Now obviously these readings will have a lot of noise. So what we do is we know that the gyroscope will drift in long term, producing constant drift errors, and the accelerometer is not good with short impulses, but is reliable long term. So we pass this information through a Kalman or a complementary filter, and what this does is it will use few mathematical equations to cancel out this long term drift of gyroscope with the short term errors of the accelerometer to give a much more precise value of the overall orientation, which involves both the accelerometer and the gyroscope readings. And precise detection. Now precise detection utilizes very high quality sensors with intelligent sensor fusion algorithms like the Kalman filter to give more meaningful data, and this can be clubbed with the next intelligent aspect of this ROV for analysis of data. Now it doesn't send just raw values, and it doesn't send just the values which we need. What it does is it will run few Python scripts to make the data more visually appealing. For example, it can plot the velocity graph of this ROV so that if there is any peaks, if there are any peaks, we can identify whether there is any obstacle or if there is any issue over in the water. So maybe this can be used to track the water current speed. And next is muddy water operation. Now this ROV is meant to navigate even through muddy waters. So it normally cameras cannot give a very good view of the water if the water is very muddy. So we can use even sonar cameras to detect the object nearby objects. Even though if the water is muddy, we can club these the camera footage to the sonar footage to get a clearer picture of the camera and faster maneuverability. Now this is one more aspect which makes the ROV very smart. So the user would want to maneuver it in one way, but because of the wind currents or because of the water currents and unwanted noises from maybe fish or any other obstacles, will uh, block the course. But then what this ROV does is it will detect what the user actually wants to move, and it will automatically adjust the thrusters configuration to match what exactly the user needs. Now this can be done by optimizing the PID constants to create a constant feedback loop through the sensors and other feedbacks to move exactly as the user needs. And the next feature of this ROV is the prioritizing algorithm. Now, let us say this ROV has some tasks and it is doing it. Now, suddenly there is some emergency, such as the battery may not be working. So, what it needs to do, it needs to first quit its task and then do the routine which is needed for uh, correcting that emergency. So that so it will prioritize immediately. It will detect even in midst of any task, and it will do whatever is needed to attend to the emergency. And the last thing is the more accurate sensing for effective trajectory. So what this also assists in manual maneuvering, and that is what makes the ROV so smart.